Okay, what I did for multiplying shortcut for problem 9 and 12 was I went back to what we did with 99 because I started with 9 on that worksheet. So recall before from when we multiplied 3 times 9, we distributed one dot from the last group to make two dots equal to 10. And I'm bringing this back to mind because, again, we're talking about grouping in groups of 10. So instead this time, they're going to start with those groups of tens and then take away the 3. So that's what I have here. We took the same problem above. We could group in tens again. This time we will start with those groups. So for the problem 3 times 9, think instead of 3 times 10. Oh, the other thing I added in here was skip counting. The reason I added that in there was because I thought it would make perfect sense when we're talking about taking away that extra set of numbers. I'm not sure if I'm making sense verbally. Hopefully it'll make more sense to my kids if and when I teach it to them. Anyways, then their algorithm, you multiply by 10, then subtract from your answer. Here's your strategy to start, the 3 times 10, and then subtracting. And then I have this. I guess this is where I'm thinking of the skip counting. Because if we were to skip count to 3 times 9, we know that it's not 30. And that's 3 more to 30. I don't know if anybody's following my train of thought, but anyways, that's what came to me when I was working on this. Was kind of like this follows along with the skip counting and just knowing that where to stop. Anyways, do you think your strategy will work for multiplication problems? Oh, sorry, that's not supposed to be in there. Any multiplication problem, you can tell I reuse worksheet. And why or why not with 9, why or why not, and then try the following. And then always the hint here with remembering the zeros, and I hope you can see that. Yes, you can. Okay. So then for the 12s. Here's what I have for the 12s. To solve the problems 5 times 12s, we can think of 5 groups of 10. So I'm kind of going back to that idea of tens where we started with the 9s, and that's why I put these on the same worksheet. And then added to 5 groups of 2. And then how many do you have in total? Write an algorithm to show how you found your new distribution. Use your algorithm to solve the first step of your shortcut strategy, always checking, and then try your strategy with the following. Hint, remember to ignore the decimals and the zeros to begin with, and then test for a reasonable answer. Jeez Louise. Sorry, I should have proved these, but I want to get through this. Anyways, the part here that I kind of wanted to get one on that I think is really important here is how is it similar to our strategy for 9s and how is it different? So again, I want them to recall that groupings of 10 again, how we're using that in the case of the 9s. Obviously, we're taking away that extra set. In the group, in the situation with 12, we've got to do that multiplication of the 5 times the 2 and add in the other groups that are missing. So anyways, that's my worksheet for that. Then for the shortcut for multiplying 2-digit numbers, I also decided to do a worksheet. And this one, you're going to have to look at my worksheet to get a better idea of what I came up with because you cannot see the color. Okay. When we multiply 2-digit numbers, we do the following. We multiply the ones, we multiply each 10 times each one, then we multiply the tens. We add them together. If we were to multiply 21 times 13, we would multiply as follows. These two numbers are these two numbers are blue, and these two numbers are red. This is blue, this is blue, blue, red, purple. I hope you're getting that. Red, blue, purple, and then red and red and red. And then when those are totaled up, we get 273. And then I kind of just brought in some general thoughts. I wanted them to think about the fact that typically when we multiply 2 ones, we're still in the ones. But if we have any extras, then it becomes a tens. And if I had to do some examples, I would, just like, 2 times 3, those are both ones. And multiplied together, I'm still in the ones. However, if I had something like 2 times 6 is 12, I have 2 of the ones and then a 10. So kind of I want them to be thinking about placement, and hopefully that'll make sense as I go on. So then I want them to try, sorry, I have a bunch of dogs living with me right now. Then I want to try another number, and we would multiply the following, and again, these two are blue, these two are red. The blue become 200, which is blue, 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 red. Sorry, blue, red, purple, 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 red, 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 and then obviously when we add these together, that's that carrying over is that I wanted them to see. Then down here, I got really creative, and this, again, hopefully if you upload my worksheet, you'll see the colors. But these two are red, and the circle is red. These two are blue, the circle is red, and then these two circles are purple. So this is blue, purple, red, and the same thing here, 2 reds, red circle, 2 blues, blue circle, purple, purple, and then the blue, purple, red. And, you know, again, chose those 2 colors because blended, that's what they become, is purple. So showing that, and then to try the problem themselves. And then this one, I want them to come up with the algorithm, you know, so I'm looking for that, you know, the 10s times the 10s, and then, you know, the 10, oh, plus the 10s times the 1s, plus the 10s times the 1s, and then plus the 1s times the 1s. So I'm kind of looking, I'm hoping that they can come up with that algorithm, which I think they can. I think it might be some time that it would take to do that, but I do think we could come up with that. Anyways, thank you again, and I will do my abacus later, tomorrow.